Hello and welcome to another episode of AI Security Ops with my illustrious panel, Dr. Brian Furman, should I say, and Derek Banks. And today we are super excited to have our guest, Colin Shea-Blymyer. I hope I said that right, Colin.
You nailed it. First try.
Excellent.
Well done.
And
So,
Dr. Colin as well.
Dr. Colin,
titles,
we're outnumbered by doctors. I only have a lowly master's degree. Sorry.
Yeah, same here.
Not sorry.
50-50 split.
Yeah. So Colin's involved in working on AI system, how AI systems can be designed, secured, governed, responsibility, ensuring that we have alignment with societal and ethical needs, all the really interesting and difficult problems in this space that we're dealing with in this human paradigm shift that we're all living through. And so we're going to talk about those things initially, but we're also going to pivot into some cybersecurity concerns because we are a cybersecurity consulting company, and that's what we do. So I'm going to kick it off with a opening question for you, Colin. And that is, you've, according to some of the stuff that we've read about you, that you've traveled kind of a journey from technical computer science over into sort of AI and related AI governance policy work. Tell us a little bit about what motivated that transition and how you got into this line of research.
Yeah, so I always knew I was interested in artificial intelligence since before I started college. As a high schooler, I was really lucky to have computer science classes being taught at my high school. I was taking those. I was also taking psychology, AP psychology. Thought just like fascinating subject. I was like, gosh, what if like there were like you could program things that like think, and then you had to decide like how well they thought at things, and some mix of psychology and computer science. Wouldn't that be awesome? And then I read Isaac Asimov's I, Robot. And of course the main character, Susan Colvin, she's a robo-psychologist. And I was like, oh my God, that's it. That's what I want to be when I grow up. And so high school, I'm learning everything I can, everything that a high schooler in rural Virginia can learn about artificial intelligence. I go to college. I study computer science. I'm doing a master's, trying to get like some real like machine learning research experience under my belt. And for a summer internship in 2019, I end up at MITRE, which I'm sure most of you are familiar with. And we are, this is 2019. So this is the first Trump administration. They've just released an executive order about artificial intelligence. And MITRE is supporting the National Institute of Standards and Technology, NIST, on developing, like looking into how we could develop standards around robustness in machine learning. We were really concerned about adversarial machine learning at the time. And I'm reading a bunch of standards and regulations about AI. So I spent like a summer reading about standards and regulations in AI. And they're all really like well-intentioned, but very like abstract and kind of fluffy, right? They're like, AI should be responsible. It should be trustworthy. It should be robust. And it's like, oh yeah. Well, why didn't we just flip the trustworthy switch when we were training this thing? That would have made it so much easier.
Oh, if we'd only thought.
Right? We just didn't have that kind of foresight as designers and developers of these systems. So I identified basically at the time like this really big gulf between what policymakers wanted AI to be and what developers were capable of getting AI to be.
Yeah.
And trying to build from one direction, building the technology that could actually give us the technology levers to pull to like align it with what our democratic systems and values are. And on the other hand, building up like this policymaker understanding of what levers they can pull to impact AI from their end. So how do I build that bridge?
Absolutely. Yeah, I think you've addressed a few of our other questions in that response, but I'm gonna plow on and talk about history for just a minute. So those of us who have been heavily sleeves up researching data science, ML, machine learning, artificial intelligence, especially large language models, we all very quickly came to the realization, and Dr. Furman here has a degree, a PhD in data science. Derek has a master's in data science, and I've just been a ad hoc mathematical guy researching this stuff. So, but anyway, we all came to the realization as we were studying the history is like, AI is not new, right? LLMs are relatively new on the horizon, but artificial intelligence technology was a dream that people were having at Stanford in the mid 50s, and a dream that you had too as you were growing up. But so, how does that history shape your research mindset? Does it impact you in different ways? How do you sort of bring that into your modern context as you're looking at this stuff?
Well, I actually have like the history of artificial intelligence as part of my first lecture when I'm teaching AI policy and governance at Georgetown. Pitts and McCulloch come up with the artificial neural network a couple of years before the first Turing complete electric computer is developed, right? So like from a modern conception, neural networks predate modern computers.
Oh no, that's fascinating. I didn't realize that time sequence was in place because that Van Neumann model had always dominated when it first hit the scene, and it kind of led us into that, from my perspective, into that AI winter period. But yeah, that's a fascinating insight.
And so neural networks like hung around. Rosenblatt built the first perceptron for the U.S. Navy. In fact, the Smithsonian Institution still has one hanging around in their archives somewhere. They've got one of the original perceptron, like these big electric monsters, that's all analog. But they were like impossible to tune by hand, right? You're sitting there like literally moving wires around by hand. It just wasn't feasible at the time. Yeah. And so part of what I teach my students, right, is that you can go back in time and you can look at Pitts and McCulloch, you can look at Rosenblatt and these really the earliest pioneers in neural networks. And then it just gets really hard to build these systems, and they lose funding. Academics lose interest. They get iced out of funding and research. And it's not until basically somebody figures out that you can use like a GPU to make these systems like quickly and efficiently that they start coming back onto the scene. And so I always have a hard time sort of believing that anything is stuck in the past, right? For decades, people thought neural networks were stuck in the past, right? And they were exploring expert systems, cybernetics.
I remember that.
Right?
Like the 90s, yeah.
I
always thought it was neat, just like Bayesian statistics has been around forever, and since the late 1800s, and it's the cornerstone of how we solve mathematical problems, right? So it's very interesting how some of the math has been around for a while. We just didn't know how to use it.
Yeah, I mean, even you look at like George Boole, right, and Boolean algebra. It predates any computer approach to Boolean algebra by like a century or two, right? And so none of this is stuck in the past. It's all a matter of the environment, like what is going to be easily implemented. Where can you get scale and power out of some technique that might otherwise be relegated to history books. And then like where do it's all incentives, right? Is there, can you find money to do this? Can you find like the pipelines, right? Like GPUs just happen to be very lucky to be useful for AI, right? If that wasn't the case, we would still be working with like support vector machines and and
some linear
Bayesian
regression
networks
here and there. Yeah.
Right, exactly.
It's kind of I don't know that it's a happy accident, but it is a design. GPUs are a design that just by the nature of what they are, the processing of vector mathematics just fit the model, if you like, of doing neural network implementation. So it's a fantastic coincidence that there was that realization, but it was almost like a duh moment too. It's like, oh yeah, of course we can do it with these things, So yeah, I find that fascinating. What about right now? What research are you most directly involved with right now, aside from your teaching efforts?
A lot of my focus right now is on AI red teaming. So one of the things, I don't know, for the audience, AI red teaming, hopefully you're aware of it already, but since you're listening to this podcast,
I think you're speaking the language of our people.
Good. Well, we have like, we're trying to come up with a nice formal definition for it. One, maybe not too formal. I'm a formal methods guy by training. Like that's what my PhD was in. So I don't want to claim something being formal when it's not. We have a nice rigorous definition for AI red teaming. And one of the things we're interested in is in how information from AI red teaming exercises can be shared, right? And reused, sort of building up a science of AI red teaming. So to put this in perspective, one of the things I would really like to see is, maybe you guys red team like a llama model, and then you red team a Quen model. And I want to know which one, like maybe let's assume you have the same like threat model for both. And I want to know like which one is going to be more secure. You might typically write down like, hey, this is like the big vulnerability, or maybe we found two big vulnerabilities on this llama model for your application need. We found maybe this one for Quen. But that doesn't really tell me how much effort went into either of those, right? What your methodology was. What are the little hints that I, as somebody who knows a lot about red teaming, needs to have to be able to say, oh yeah, that's how I would have done that. Right? I would have done the same thing, or that was actually a really clever way of doing this. And I think that this report is really valid, right? They had a really clever methodology. They did a really good job. They spent the right amount of resources and effort to do this. I can trust what they found. I can trust that these two vulnerabilities were like the big bad ones and they didn't miss anything major.
Yeah, I think that's, on the red teaming topic, one of the things that sometimes gets us a little derailed, but is still just as valuable, is we're finding that the surrounding scaffolding around model deployment in modern corporation and commercial enterprises is actually, it falls back to standard web application testing, but it also has become a problem because for some reason we're going backwards in the developer mindset of how to build the scaffolding around these things. And it's usually when I say backwards, I step backwards in the security mitigations that are built in. So our tests have tended to fall back into finding vulnerabilities in scaffolding and less as focused on the models. I don't know, Brian or Derek, do you have a thought on that?
I'm gonna let
Yeah,
Brian.
I would. Yeah, no, I would agree. And I think that part of that probably comes from the AI boom and the hype surrounding it, and these companies just wanting to get a product out as quickly as they possibly can. They see that the demand is there right now, and being first to market means a lot when it comes to generating interest and generating revenue. And so then these teams, they might come up with an idea, or management comes to them with an idea, and they're like, hey, we want this now. And as we've seen before, over and over throughout the years, when things get rushed to market, security is often kind of an afterthought. And I think that that's kind of what we're seeing again with this.
Yeah, I like to break it down into two like categories, right? I think you have AI safety and you have AI security, right? And I think that from what you were saying about like you have these two different models and we want like a baseline to like test like the models themselves. A lot of that ends up being like safety oriented, like bias and can you get past internal guardrails and stuff like that. But then like Brian was saying, you have web app stuff around it where we're finding that like some of the stuff that is maybe, we haven't seen recently in web app tests are being repeated as flaws as people are implementing stuff. And we have certainly examples from tests that we've done this year, but something else you said really made me think about like the data sharing aspect. Like historically, penetration testers and red teamers, like folks in the information security community, do not share data with each other on the red team side. Now, on the blue team side, it's completely different paradigm, right? Like you have, like frameworks in place, for sharing cyber threat intelligence, right? Where you have different TLPs, right? And so, different colors. And so I think that starting with some kind of like framework for folks to be able to share information, like I just don't see that exists. And then one other thing that a colleague of ours mentioned, he works for Palo Alto now, that he's working on, and it's more around like writing the reports, but essentially having all of your command lines like recorded and then have an AI summary of everything you did at the command line, like goes like into the data. But yeah, the data sharing aspect is huge. And that's a barrier that I'm not really entirely sure how to get past, because people, I mean, we're actually fighting at Black Hills, just folks using frontier models because they don't trust OpenAI or Anthropic. And we're like, well, but you trust Microsoft and Amazon. What's the difference, right? And so, yeah, there's a lot of work to be done on red teamers sharing data and techniques, I think.
Yeah, I want to, if I can, respond to this like security versus safety, because I think there's something there. I would argue that there is safety on models. There's also security on models. So like you can expand your scope, right, from the model itself to the system around it. And I think that there are really interesting security problems right on the interface of, right, oh gosh, I just saw an article today about there are all these new like AI powered browsers. And they're reading text off of images, and you can put prompt injections in images, and then it reads it off of the image, and that's
now
like
the security folks are like,
right, and it's like, yeah, like that's not great. That's like obviously some sort of security vulnerability, but that is only a security vulnerability because the way that we treat AI models and the way that we treat the information that goes into them is so general, right? We would never be like, hey, like, we're going to throw SQL queries into our database. We're just going to we're going to scrape a website and throw whatever's in there into our, as a query into our.
We're going to let the user input dictate what we put in.
Right. Like that's insane. like obviously we're going to put some guardrails on that.
Yeah.
It's just that like the guardrails for what we want AI systems to do are way more like flexible and wavy and diffuse and foggy. And so that's where like security and safety start to meet, in my mind. And that's where that like really exciting frontier is for me.
Yeah, there's definitely a Venn diagram there, but
yeah.
I think that, our take on it, or, our take is that there are things that are clearly safety and clearly security, but there's definitely overlap. And that seems to be where the implementation meets, right? Where you have agency and, user sanitization, all these things that we need to be concerned about. And like Brian was saying, well, you can't be concerned about those things and get that product out next month, right?
Yeah. Well, we're going to try to carefully avoid the agency topic because we'll be here for the rest of the day.
Well, that's true. Yeah.
So, but I do want to ask a follow-on with regard to your research focus. Have you started to look into, as a part of that research effort, any of the ML ops pipeline, the data scientist side of this as they're building models, and how that impacts your rigorous definitions for different security risks?
We're mostly focused on the reporting sides of things right now. So it's less on, it's less on what the risks are. I have done a little bit of work with like OWASP on some of their risk scoring, their AI risk scoring, stuff, only a little bit. But my main research focus is on how AI gets reported, right? So if that vulnerability is from a specific part of the pipeline, right, a part of the AI development pipeline, like that should definitely be reported. And I think that's part of let's see, I'm trying to think here real quick. I would guess that's part of how you're defining the scope of your red teaming exercise, right? If the pipeline is game, then attack away, and see if you can really screw things up that way.
Yeah, I get the sense it's been less of a focus of our community as well, just mainly because it would presume that there are a lot of organizations out there developing their own models, and I just don't think that's actually occurring because of the cost for the large scale efforts. Is these vendors are bringing forth the solutions for them.
That's a really good point. I have been thinking a lot actually about the relationship between mitigations that you can do after the blue team side. You've done AI red teaming. And you're like, yeah, well, like you've got these vulnerabilities. We'll slap this guardrail on. We'll tweak the system prompt in this other way. But like we're not going to retrain the thing. Like we don't have the resources to do that here. And in a similar way, like as a red teamer, like it's really hard. Some of these things are really hard to have the resources to do, like to attack like the data sources, right? Like, I mean, well, it turns out that you only need like about 250 poisoned pieces of data in a training data in order to like inject backdoors. This was some research that came out of the UK AI Security Institute. But which is like pretty scary. But like it's there are different part, right? Like it's going to be hard to, I don't know, like put a vulnerability in PyTorch for the average red teamer.
I mean, I would argue that the average red teamer would be afraid that they're going to commit a felony if they're going to do that, right?
Yeah. Well, that's right.
The Computer Fraud and Abuse Act is,
the supply chain risk side of this exists, there's no doubt.
But it's no different than other things too. Like I'm not going to compromise Verizon so I can, basically do a SIM swap on somebody, but a nation state threat actor might do something like that. So you can't ignore it, but it's hard to test, right? And that's probably why, practically speaking, we kind of default back to, well, like we should really look around like the web at, like the vulnerabilities that surround it too. Because for a company, for their stuff, that matters a lot more. But I mean, also, some of the other things also matter to them. Like if there was a backdoor implemented by a nation state threat actor, well, look at was it SolarWinds? It could definitely make a bad day for you, right? So it's still a problem that we collectively need to worry about, but. In the average assessment for one of our customers, it's just not something that we can do anything about.
Yeah. Hey, so I'm going to pivot a little bit here really quick. I went on a little bit of a dive down into the legislative efforts that were going on in the United States a while back, and we actually talked about it on a couple of episodes on the show. And you mentioned early on, as we were just starting out today, that that you'd sort of done a similar thing. And the one thing I found in the United States is that there's this patchwork of attempted legislation efforts that are very lightweight, they're kind of fluffy, and they're typically are focused on sort of a specific concern, like protecting from harmful bias or something like that. Or that's probably not a good example, but on the other hand, there's not been any really strong federal efforts that I'm aware of. But the flip side of that is in Europe, there has been some very forward-thinking kind of heavy efforts on the regulatory side of AI. So can you kind of compare and contrast the differences between the EU and the US and kind of where we sit with the regulatory efforts?
Yeah. Gosh, I think one of the first like AI regulations that I was at all aware of. So I did my PhD at Oregon State University, go Beavs. And part of being in Oregon is being aware of what's happening in Portland, even if you don't live there. And in Portland, they had just passed a law. This was years ago. They had passed a law saying that they wouldn't allow like facial recognition for law enforcement. And this was like pretty early. This was like probably 2019, 2020. When they did this, and like this makes sense for Portland. Like this is like a pretty like representative like kind of effort for the kind of person who lives in Portland. That makes sense for a thing that like the average Portlandian would want. Um, New York City, a couple of years ago, passed a law saying that all hiring algorithms, any algorithms involved in hiring, would have to pass bias audits.
Interesting. Yeah.
Yeah. And so there is, I mean, I think it's like unclear what the teeth to some of these laws, some of these like really, I would say like hyper local laws are. They typically don't have like the enforcement mechanisms to really, especially like the New York City one, to really like crack down or even investigate any violations of that law. But they're on the books, right? And it is an expression of like, you know, the demos, the people, and their attitudes towards how AI should operate around them, which I think that's pretty valuable. At the state level, I think the biggest news has come out of California, right? I think the failure of the last AI bill and the most recent passage of the sort of updated version, was that SB 53, I think. This shows, like, again, the willingness for larger populations to start to regulate. Now, of course, the California effect is, I think, what California is going for here, right? They want, right? They have sort of outsized leverage and influence on not only on like the political landscape as a whole of the U.S., since they're a huge state, but also on software development, right? Because most of the model developers, I think everyone like out of the big like five, if you include Microsoft, they're in Washington. Grok XAI is in Texas. Everybody else is in California, I think. They have a lot of leverage over what happens when it comes to AI development. But I think that it is like, I don't know. I think it's one of the key benefits of living in the United States is that we do have these laboratories of democracy scattered all over, you know, and I think that we should really take advantage of that when we are in such an uncertain time as with AI. I think I'm not a fan of the idea that has been floated in the US that we should put a moratorium on state level regulations of AI. I mean, patchworks of AI regulations like aren't ideal. It's not great. But it's also the right of each state to be able to do that. And I think to violate that right is,
I was gonna say, good luck telling a state that they can't do something.
right, exactly.
Well, and I agree with you on this, that it acts as kind of a development source with everybody's different perspective of different regulatory approaches that might be able to be eventually amalgamated nationally, right?
Yeah.
So it's not necessarily a bad thing.
Mm-hmm.
The tendency in the United States, though, has been to innovate first, regulate second, whereas the EU has this tendency to regulate first and just see what happens. Have you got thoughts on that aspect? What's better? What's worse? Pros and cons? That sort of thing.
Yeah. I mean, I think it actually really depends on the kind of regulation that's happening. I think that in many ways, GDPR, right, the Data Rights Act in the EU, has been seen by its citizens as a success. You know, they have a lot more control. I mean, a lot of it is tied up in like dark patterns and which button you click to say which cookies you accept. But you know, and the whole, they get that choice, and it's afforded to Europeans, and they like that. One of the criticisms I hear about the EU AI Act is that it is not rights based. It is not designed to protect any specific rights. It is to impose procedures on AI developers, right? And so this is like, unfortunately, the nuance here is really important. That just enforcing procedures, when we don't know what rights they are that we are trying to protect, can be really tough. But it might be more palatable than saying like, yeah, we don't want systems that are going to cause financial damage or bodily harm to people. And we can't just say, make sure your AI never causes financial damage, because when it does, what are we going to do, right? It's like, it's too late. It's too late at that point. It's hard to predict what might cause, this violation that we're trying to avoid. And so that's why, they turn to one of these like procedure-based regulations. Trying to understand those procedures, like in and of themselves, I think is a huge area of like research and concern in AI governance, right? And I don't think that we have the impetus. I don't think we have the incentives in the States to really dig into that very much outside of academia. Right now in the EU, there's going to be a debate between Brussels and the AI developers on what are the right procedures, right? The starting gun has been fired. Now they're going to innovate about what are the right procedures to avoid the kinds of harms that the populace is worried about.
So doesn't that ultimately have the effect of actually repressing innovation? I mean, it feels like it would.
It'll repress a certain kind of innovation. It'll repress like the raw capacities of AI systems, the raw capabilities, but it'll also inspire innovation around what kinds of testing and evaluations should be required of AI developers in order to guarantee that there is some base risk of harm or base non-risk of harm. So it depends. It really depends on what is a populace's risk tolerance to these things. One of the curious things I think that is a result of this is that the U.S. is at least by I think Pew came out with a poll fairly recently that said the U.S. is one of the most pessimistic about AI in the world. We should be thinking about if our risk tolerance is that low, we should really be thinking about what are the procedures that we care about, what are the harms we want to avoid. But that doesn't seem to be reflected in policy land in DC, where I am speaking from right now.
Yeah, that's because everybody's seen the Terminator movies in the U.S. and they're like, no, we've seen how this ends.
Yep. As soon as I moved to DC, I was in the DMV. The lady behind the counter is she's doing the paperwork. She's asking me why I moved to DC. It's like, oh, well, I'm doing research on AI. And she looks up at me, looks over her glasses. Is like, they make a horror movie about how AI goes wrong every year. I was like, yeah, well, I figured I'd get this under my belt. Then I do an internship at the Ouija board factory. Then I heard there's a dinosaur park that needs a few hands. So just trying to make the rounds.
Yeah, it's a fascinating. I mean, I think policymakers and citizenry alike, there's actually no true understanding of what's really happening, and that is a difficult gap that's going to take a while. And you got all these different vendors that are fighting for market dominance and to give their version of what they think it's going to be to people that are going to use their services. But I think we sit in a bit of a privileged position because all of us are deeply involved and we got sleeves up and we have this knowledge that that frankly, well, for me, sometimes keeps me up at night and scares the living crap out of me.
I think the pace of it is really what's terrifying, right? Because I hear people, talking about, even if you look at things that revolutionize the internet, like cloud computing or virtualization or, containerization, blockchain, whatever, it seemed like it took a little bit longer for the ramp up. I mean, I got my master's in 2020 and 2021 from UVA, and we looked at GPT as kind of like a toy. Like, it wasn't a focus, right? I imagine now the curriculum is probably a lot different, and even with it just in the last year, just the how much better the frontier models are than they were a year ago, it's really astounding in my opinion. So I'm not even sure where it'll be in a year or 2 or 3. So to try and sit down and make legislation about it, like, Wow. I mean, if I had to make a choice, it would be it would be not necessarily legislation as much as it would be kind of like a Manhattan style project to protect the big tech companies from, model theft and things of that nature. But hey, I'm not in charge. So,
Yeah, well, and that's a great segue to our next question, which is, and I'm going to try to get this and kind of wrap it up towards the end here. But really, it's I'm going to sort of combine this into one long question, and that's, given today's environment, what are the top emerging risks here that we really have that intersect AI and cybersecurity? That's part one of the question, and then per the open model and the open source community, a sort of tangentially related question is, how do you feel about the concepts of open weight versus the idea of maybe becoming a lot more open and publishing the actual neural network architecture, perhaps the data sources used? So I'll let you start up with just sort of a generalized emerging risks, and then we'll go to that one.
Yeah, there is a connection here. I think that a lot of this depends on your personal appetite, right? And I think that this is the fight that we continue to see borne out both in the technical debates and in the policy debates around AI, right? What is it you're afraid of? Are you afraid of AI is, we're plateauing, and what matters is like biased and fairness in AI systems, or what we really need is like a few more years of really intense innovation, and we'll have systems that are curing cancer? Or is that going to go too far, and we're going to have AI systems that, Mark Milley said, are going to be positioned to be making military decisions? If you're in the latter camp, you want to outcompete China. And that is the number one thing that you care about in the world. And like models being open, you don't want any of that. You want to batten down the hatches. You want to pour money in. You want to make sure that the U.S. beats China, and we come away with the most powerful, super computer, super intelligence that we can dominate the world with. If you're in the middle camp, right, and this is where I think people like Mark Andreessen is, and Horowitz, right? Like these are people who are saying like, yeah, we just need to innovate. Right, everything's going to be great. We're going to end up with these like engines of the economy, and we want like basically to have the new industrial revolution based off of this. In which case, you're like, yeah, we'll regulate later. We'll regulate when we've got like the golden goose. We'll figure out who gets the eggs then. And then if you're in the first camp, right, maybe you're thinking a little more like Europe, and you're saying, look, like the harms are real. People are getting hurt by these things now. We need to get procedures and policies in place, right? And in that case, like open models are great, because what you're able to do there is do tons of like really interesting research, from open weights all the way to like more open models on that spectrum of openness. Those are all going to give academic researchers the ability to play with things that you really can't do otherwise. There's a great report coming out by my colleague Kyle Miller on some of the research that you can do with open weights that you can't do with closed models, and really like teasing apart this argument that like that you're actually you are actually giving research a gift when you're opening models.
Yeah, your some of your comments reminded me of a couple of books I've read. One of them was The Coming Wave, Mustafa Suleyman, formerly of DeepMind. He was very, I would say, full of regrets, was my impression from that book, about what he had wrought right over time, and was really in that camp of we got to protect everything, we got to regulate everything, So it is interesting. I think the big beautiful advantage of the United States is we do tend to push innovation over these other safety concerns, but that has its costs as well. I'm going to pitch it over to Dr. Furman. Brian, if you would just ask the the final couple of questions and close us out, that would be fantastic.
Yeah, sure. Let's do that. I'm just going to go ahead and skip down to the bottom one here, and then we can go and close it out, which is what's one practical takeaway you'd like listeners to remember from this whole conversation?
Yeah, I think the best takeaway, given this conversation, the way it's gone, is to be really aware of what it is you want from AI. I think that it's really easy to get caught up in the hype, to believe all the marketing and all the doomsaying, right? To figure out what it is your expectations are and what your risk appetite is. Spend some actual time thinking about where you think your AI application is going to be used, where AI is going to develop in the next 5, 10, 15 years, and what that means for, your organization, for your community, for your country, and act on those beliefs if they are certain enough. Or maybe you have really high uncertainty like I do, and you just need to keep digging, right? And then you join the masses of researchers who are still trying to figure all this out.
I was going to say welcome.
Right.
Yeah, I do think you have to, if you're in this space, you certainly have to be comfortable with non-determinism and comfortable with uncertainty, because that's the nature
that's why
of
I've been so calm recently. Is like my whole day is like, I don't really know what's gonna happen.
Yeah.
So.
According to Ray Kurzweil, the singularity is nearer, and he predicted that the merging of artificial intelligence and biotechnology is going to occur, and we'll end up with the superhuman advanced merging of machines and humans, if you like, somewhere in the 2030s. I want to hear from everybody. What do you think about that notion? Do you think we're really heading there?
I'll start. No, not by 2030 or the 2030s. I think it's going to be fast. I think the world's going to be a different place very soon. But I think we're going to have much more societal issues to tackle before we have, basically neurological implants that everyone adopts that allows us to think at the speed of thought and become a collective hive mind, or whatever the singularity really means. Now, is that like the ultimate, like what ends up happening? Yeah, probably. Right. I think that eventually, but I don't think it'll be, and I think that particular thing will take a little bit more time. If I had to pick like a sci-fi series to think is probably closest to the truth right now, I wouldn't go with The Matrix. Actually, I'm going to go with Dune, where we actually, get really tired of all this AI stuff when it tries to kill us and we wipe it out. And then we make humans better, and it takes 10,000 years or something like that. But,
right.
But yeah, I don't know about the singularity, but I do think that there are some real interesting, like concrete problems that we're going to have a lot sooner than we all really want to admit. And I think that has to do with, knowledge workers being replaced by AI type stuff. And I think that's coming first.
Well, I think arguably we're already seeing that.
We already are seeing it, absolutely.
Yeah. So to that silly notion of the merging of humans and machines, Dr. Furman, what do you think?
You two have to still answer.
No, I agree. I think that maybe at some point, but not by the 2030s. We've seen huge advances in AI technology. In particular with large language models within the last few years, last decade, however you would like to put that span out there. But in terms of fully integrating that into our normal, being of what makes us, I still think we're probably a bit off from that. We are already seeing some of the technology that can kind of lay the groundwork for that, right? With like the Neuralink implants, which they're having amazing results with, which I don't know if you guys have looked at any of that or not, but basically people who are, quadriplegic being able to play video games just by thinking about it and training about, or, training their mind to do it. Outside of that, I've seen people play with like less intrusive technology with like brainwave scanners where, people will come up with all these different self-imposed challenges to beat video games. And one of them that I've seen is a person who has one of these brainwave analyzer things, and they train themselves to be able to play the video game with it. And so, we've got already kind of that meshing between like our thoughts and computer processing. But I do still think it's going to be a little bit off before it's widely adopted and really integrated into everyday life.
Oh man, I was hoping you'd give me the answer that I can upload my brain right now. Colin, I'll let you have the final word.
All right. Yeah, to like really engage with the prompt here, I would say that 2030 sounds like it's a little too soon by my calendar. But I think that there is a scary fine line to walk between having AI systems that are advanced and helpful enough for us to like integrate with them, and having AI systems that are advanced and helpful enough that they get misused to do great harm to humanity or control risks, and they go off by themselves and destroy humanity without humans helping them. And finding a way down that narrow path, as it were, to get to a place where we are helping ourselves with our technology, not hurting ourselves with our technology, which has always been a difficult thing for mankind.
Yes.
Walking that line, I think that'll be the true test.
Absolutely. That's great comments. All right, Colin, thanks for sharing your insights and coming on the show today.
Thanks for having me. It was a lot of fun.
Yeah, I really appreciate it, man. It was awesome.
Yeah, thank you so much.
Absolutely. Thanks for the invite.
It's been great. And so I'm trying to invent another tagline right here, but just so everybody out there, just remember that we are living in a world of the intersection of non-deterministic, probabilistic technology and prior deterministic technology, and this is going to continue to be a bumpy ride. So be safe out there, keep on prompting, and we'll see you next time.